Good evening, everyone. Let's continue with the lecture first, the chapter 1. So this is the introduction. So that means we'll give you an overview of the database. So it will include all the contents we want to cover in this semester. So it's also an important one for us to understand. That means the overall contents of database. So let's continue. So basically for today's lecture we can cover the first three. So we'll talk about first one is that why database is needed. What's the difference between what's the advantages between the database and the preferred file system. And we'll look at the data. That means how data will be modeled and how data will be created, maintained. So that means how to use the database. So we talk about different view of data. For example, like we mentioned, the logic view, physical view, or view. That means create a view of database. Let's look at the first one, database system applications. And then next week we'll continue with other things like different type of database languages, how to design database, and database engine. That means what's the functionalities will be available in a database engine. For example, like MySQL. That means you will use this DBMS to maintain the database. And then database architecture. So that means how to understand different database architectures. Database user and administrators. That means from this different users of database, what's the functionalities will be available for them. And then different database, that means system history. Okay, let's look at first one. So first one, we want to differentiate some different concept. Here we have many concepts. The first one we said is the database, so DB. And then we also have a database system. And then we have a database management system. Okay, like these things. So we want to differentiate. So database usually is seems like just only the data, correct? But in fact, database is only the data. We don't know how to utilize the data. It's not possible to utilize the data. So usually database means it contains not only the data but also programs. Okay, the programs. So if we add these things together, we said it's a database management system. That means under this one there's a database, but on top of this one there's some software. So for example, like we said, we have MySQL. So MySQL can help you to create a database, create a table, insert a record to a table, or retrieve data from the database. So this one is not data, correct? It's software. It's some programs which can help you utilize the database in a convenient way. So if we consider all of these things together, we will say this is a DBMS, database management system. So it also contains the data but also has programs and an environment that is both convenient and efficient use. For example, like user interface and some other internal optimization engine. So that means all of these things together will form a DBMS. So that's why we call out the design of DBMS, okay, of our course. So that means not only the data but also the related programs. So if it's only a database, we can say it can port this database in different DBMS, for example MySQL or Oracle or SQL Server like this. Then we differentiate this one, something like a database is only in this part, okay, database. So that means the data itself, okay, the data sets. Okay, so sometimes we are confused with this one, but yeah, need to look at the scenario where the terms are used. So next one is our target. That means so why we want to collect a lot of data together and create programs to utilize them? Just because we want to reuse them. They are important and they're large, and we want to extract information in a convenient way. Correct? For example, we do retrieval. We want to count how many people have registered 4 courses these semesters. Okay? Like this query. So in fact, we cannot prepare these things because you cannot exhaust all of the cases. Correct? So we can only save the atomic data there, and then we, based on some calculations, we call it queries. Of course, these queries will not be implemented by you. You just need to utilize a program language. We use SQL. Okay? So it's end user use SQL, and the SQL will query the database. So how to query these programs? We'll do this one. For example, query. We also have a query engine. Okay? It will do optimization to find the data answer as quickly as possible. So what you need to do is that you need to know how to write a SQL query for this one. Of course, it's also need to be done by people. Okay? We cannot do it in advance. So that's the reason we have a database, we have programs, we provide flexibility for people to utilize the database, and then for programmers, they can write SQL queries, and for users can use those SQL queries to query. So that's why if you log in your SOAR, and another student log into his or her SOAR, so we get the same. The SOAR, we got the same user interface, because that's based on I think based on PeopleSoft. Okay? And then, but the difference is that you will get your own, the student 1, and the other student get student 2 get his or her own records. Okay, and also maybe for both of you can get similar information. For example, the courses schedule, the course schedule, all the courses, the timetable, and so on, okay? And like this information. So anyway, you can think about this is like what? So that means we have a database under this application. It can provide general queries, but it also can provide specific queries. For example, specific to you. General queries like the public information everybody can access. So we said that if we want to use this database just because we have the requirements, you can think about database DBMS is also a software. Okay? It's just a specific software. It contains data and also a specific database management system, which is a collection of programs. So of course, if we have programs, you only have input, output. So input for here is the data, output is the query result, or you do some update and so on. Anyway, it's just the resulting database state. Okay? So that means we want to manage the collection of data that are highly valuable. If they are not useful for you, nobody want to maintain them. Okay? Just because we utilize this data, we use them, and we keep a record for them, it will have important impact on the future. Okay? And relatively large. If it's small data, I believe you can just use Excel, use a table, whatever. Okay? Just because it's too large, it's not easy to manage based on those tools. So that's the reason we want to have a database which can utilize some existing software programs to process, to utilize, to maintain them. Right? And also the other reason, this one is like a valuable large the size. Right? This is value, this size. The other one is accessibility. For example, if this data is only located on one computer, there's no program which can be accessed which is provided for others to access this data, then it's not easy for people to use, because that people need to utilize to maybe to come to this location and then log in and then use the same username and account and then access it. Just because of this reason, we want to have this data be accepted by any of you, okay? So all the students can access the source if they have a network, and then it can also be accessed at the same time. So that means it's pair 9 access. It's just like a, so we said this is just in operating system. Okay, we have two concepts. So this one just like access something at the same time. Okay, not like you accessed a while and then let another one access. So if like this one, we need to provide really just like a multi-user, okay, multi-user access ability. So how can we do that? We have to use database, because database has that concurrency control. So we will make sure each user can access the database at the same time, but not hurting the consistency of the database. So we need to have programs to handle this one. This is also covered in the transaction chapter, okay? Maybe chapter 17. So for this reason. So if somebody makes something wrong, so that transaction will be rolled back rather than just partially done. So this is the reason we want to have a database as well. Okay. And a modern database system is a complex software system I mentioned, okay? So database you can consider as a collection of software. So because you can find out, for example, when SQL Server, okay, is in Microsoft production stage, in fact people just develop a program to handle the general usage of the database and then provide them as a tools. So you can use it as a tool to create a database, to design, to create, to use, to maintain, and whatever, okay? So this is just like a general pipelines, and then they create tools just software, okay? So that means it's a collection of software which can be used to manage a large complex collection of data. If it's small, you don't need to use a database, okay? And also complex, so that means it involves maybe a lot of tables, not only one or two tables. They also have many relationships between the tables, okay? And also database is everywhere. Database is everywhere. We use database every day, okay? Every day. You can think about you logging into your bank account, your SOAR system, or you go to the Amazon to shop, and even you go to Walmart to buy something, right? All of these things you need to use database, right? That's the reason. And here we give some applications. That means just give you the reason why we need to learn database. Just because it's everywhere, I believe in the future you can find, okay, there's a lot of jobs which requires this knowledge. They also maybe focus on this part, just database, DBA, or you focus on database creation, maintenance, whatever, okay? Even you don't specifically doing this one, but still will involve this one. It's a must. Even like a cell phone, okay? Because I also ever worked as a software testing engineer in a mobile phone company. So in fact, when we developed the software for the mobile phone, okay, for that time it's a CDMA. We developed some CDMA. We sell them to a lot of countries like India and maybe East Asia, and many countries. Okay, maybe not to USA because at that time maybe CDMA is I think it's between 2005 to 2007. I was a software test engineer. So basically, I'm focused on integrated testing. Okay. So in fact, for this one, we also have a small database. For example, like your phone. Okay, your phone book. You have cell phone, and then you have a lot of phones. So, and also maybe for other, this is the only one. So even for others, you may also, for example, you have a game. If you have a game, you need to record, okay? So what time you get, what rank, what score, like this, also saved into a database. So in fact, database is everywhere, really. Even you do mobile software development, it will also involve database. So like this one, enterprise a lot, okay? Like especially like a retailer and so on, okay? This one sales. For example, one is sales like okay, we have a lot, okay? Retailer. So we have customers, we have products, we have purchases. We may involve something else. Here we maybe didn't mention about the company's information. Company also have personnel, and also maybe they have some storage, and they have some employees, and so on. If you want to put them together, will be also a bigger one. But sometimes we can separate them from. Well, we didn't mention them just because we want to separate these two systems from each other. One is maybe we can say human resource management. People soft like these things, we can use the software, use this system. And the other one is like their business, okay? So here is only focus on the business. So you can also think about whether you want to integrate them together or not. Sometimes maybe it's not a good idea to mix them together. So here we only focus on the business. So customers, of course, for sales is between customer and sales company and retail company, and also the products. The customer buy product from a retailer shop or retailer website. So this one is a relationship. Okay? We have a customer, and then we have product, and then we have retailer company. So that means that we have this relationship. It's something like we have this. This is three parties. Later we talk about sometimes we have this relationship. Okay, sometimes maybe it's simple. We only have two body, only two body. But here is like we have three. So how to represent three? We just use this to represent, and then put a relationship inside. Okay, relationship in ER diagram we use this, and then entity we use this one. Later we talk about entity. We separate the ID, the entity name and its attribute using this rectangle. This is for example customer, and then attribute 1, attribute 2. So attribute means you want to describe the aspects of an entity. For example, like the customer. So maybe you can have customer ID, name, address, phone number, and so on, like these things. Product, you have maybe part number, and maybe you have the internal, for example, using some other number to identify this product in that stock. So item number, for example, and also product name, price, and so on, like these things. And then the purchase is this one, the purchase. So purchase. So the customer purchase a product from a retailer, like this relationship. Okay, and then we continue, for example, like accounting as well, payment, receipts, and sets. Of course, human resource, employee, salary, taxes, and so on. So this is one example. Enterprise is very big sector, includes a lot. And then we look at the other side. So products were produced by manufacturers. So manufacturing. So also they have some inventory, because they have materials, the source raw materials, and then have end products. So you receive orders from the maybe retailers, and then have the supply chain, so parts information. Just consider a car builder, a car maker, and then it also need to purchase parts from a lot of companies. You need to maintain the inventory of the parts and the inventory of the produced cars, and also receive orders from, for example, car dealers. And then they also need to arrange the production, so what time we produce what things, like these things. Okay. And the banking and the finance. So this one also a large body of large body of companies in our daily life. Okay. So for example, like banking, we have a bank account with the company. So basically, you can access your financial information in the bank's website, just because you have the records saved in the database. You can access that information 7/24, just because you have that records in the database. Correct? If you don't have an account with a bank, of course you cannot do that. So what's the typical things you will have with a bank? You may have an account which is a saving account, which is a checking account. You may have some account which is a loan account. Okay? You can save money there, but you can also borrow money from the banks. Okay? So that's why banks just the product is just they borrow money and then sell money. So this is they get money from you and then loan the money out to some others, so they can make money, can make profit from this difference. So you save the money in the bank account, then you have accounts, and then you also need to know what's the holder of the accounts. You have your customer's name, address, and the cell phone number, and so on. And the accounts maybe have also the most important is account number and account value. How much is in that account number, and transactions. You have to deposit, withdraw, and so on, like these things. Okay. And then also credit card transactions and finance, sales and purchase of financial instruments like stocks and bonds and market data. So same information you just use. For example, you buy stocks, you sell stocks, and so on, like these things. They will maintain these transactions. They will record this one, and then they can help you to buy stocks. You cannot buy stocks directly by you, so you have to utilize their service. So the financial companies, they will prefer such services to represent you to buy or to sell. And then the other one is the universities. So it's also another great example for us. In fact, even our book also use this one as an example to explain many things. Later we will further explain this one today. And then universities, we have courses, students registrations, and courses, instructors, departments, and schools, and so on. This information. Okay. And the airlines. Okay. We have airlines, reservations, schedules. Yeah, we do have maybe a option which can help you to do this one. Maybe it's option 5 or not. You can just consider. I'm not sure whether I listed this one. Yeah, you can confirm later. So maybe you can confirm now since I already opened this one. yeah, maybe it's option 5, but I didn't include this one just because maybe it's a little bit easier compared to others. So that's the reason I didn't put this one here. Okay. And then telecommunication, for example, like AT&T, Verizon, like these things. Right? Like your cell phone, you will have a relationship with the telecommunication companies. Okay. So records of calls, incoming call, outgoing call, and text. Okay, messages and the data. Okay, use mobile, wireless, generating monthly bills. Okay, they need to do these things. Maintaining balances. So here maybe it's only like a functionality. Okay, not only just say, okay, this is a table for this one. Maybe this one involves a report. Okay, report is like a send a query. Okay, so they're not maybe not the bills table, but they will just do a query based on the calls and the text and the data, and then generate the bills. So the database DBMS has this functionalities just because we already wrote the queries to do this. You can generate monthly bills, maybe weekly bills, maybe so on, but this is up to you. You need to write the queries. So the database, you need just maintain the basic data. So we need to build on top, to build the queries on top of it. Okay. And the maintaining balances on prepaid calling cards. So web-based services like online retailers, Amazon, sorry, Amazon. And then for this one, so we have order. So many companies, they are both online and offline. Walmart, Costco, Amazon, I believe maybe we have some stores that without people. I think in Seattle, in CA, we all have some stores without people. So it's you just scan and then go away. Okay, you receive the bill. Okay, just order tracking. For example, you submit order. Okay, and customize recommendations. Amazon use this a lot. Okay, so you visit Amazon, they will recommend a lot to you, which may be your favor, just because they record your previous survey records, surf records, and the online advertisement like Google Ads, they will recommend related ads to you. Document bases. Document database, that means is documents, for example, for the legal service, like these things, and for government service, immigration services, they maintain a lot of documents. Okay, even for the drive license office, maintain these things. So you need like a document means you need like a digital version of the paper book, like these things. And the navigation systems as well. Okay, they need to maintain the locations of various places of interest, along with the exact routes of roads, train system, buses. So they have to do update for these things, and then quickly changes after we have built new roads and so on. So that's why Google will capture your house maybe every year, just because they need to update the roads, update the information. Okay, so GPS, of course, seems a little bit simple, but in fact we have a lot of information. There are roads, train system, buses. Okay. So let's continue for the next thing, the purpose of database systems. That means why we need to create databases. What's the advantages, benefits? Okay. So here we list several benefits. That means why we want to have databases. This is here. Okay. In fact, when we talk about the databases, we want to compare with the previous system to maintain data. We call it file system. So you are not new to this name. File system, yes, it's correct. Just operating file system. So before database was there, we use a file system to manage data. So you consider we use a lot of files. Maybe you use tree-based, use group them into folders, subfolders, and so on. A hierarchical one. But do you think it's a smart idea to maintain a lot of data? Small amount of data is okay. For example, even till now, for common people, we still use this file system to manage our data. But we do have large databases which are managed by professional person just because they are big, they are large, cannot be used in that way. Use the older way, use a file system. Older way may be still possible for us, but in the future we don't know. Use more and more data, we may also need to have a very good database management system in our local computer as well. It's possible, because we have more and more data. We generate data every day, and we have a lot of historic data in the past, and then we want to maintain them in a good manner. And we may have a lot of copies as well, the online, offline. So we may need to synchronize both, maintain the consistency between them. Okay. So that's why if using file systems, we can have a lot of problems. So just because the preferred file system have this problem. For example, the first one is redundancy. Redundancy. You may have a lot of copies. Inconsistency. If you have a lot of copies, you change this one, but didn't change another one or another ones. So you have a consistent issue. Some are correct, some are not correct. So that's called inconsistent. Okay. And the other one is that using a file system, we feel a lot of convenient as well. So difficulty in accessing data. We have to write some new programs for each new tasks. So because you use a file system, you can only open a file, read a file, write a file, close a file. So if this time I want to count how many people registered in my CSC 411, a write program. So next time I want to know how many students registered for my CSC 413. Though I can still use the previous program, but I still need to have a separate program, or update. So back and forth, so it's not convenient. Rather than like this, okay, this time 411, just input 411 in input text box, and then next time 413, CSC 413, input that one, and then we'll select that one, and then do a retrieve, click a button, and then we return the result. So the changes is only the course number, others doesn't change. So in fact we coded this one as a SQL query, but in the past, in the file system, we cannot do that because we don't have that code, we don't have that functionalities. Okay. And the other one is data isolation. Data isolation means data changes in one, whether we need to have concern on other copies. So for here we have different copies, and also the same data may be saved in different formats. So it's not easy to isolate the files from each other. If you want to change one, you also need to have good memory, or at least you need to have the checklist. Okay, you need to redo the similar things for others. So this is called data isolation. Data isolation, you can think about, like for example, when I handle one data, I can just ignore other data does not exist. So this is called isolation. You isolate yourself, means you don't want to see anybody. You think anybody is not there. Okay? That's called isolation. Isolation, that means only concern is the current one. There's no concern on others. It seems like others are transparent. Other things are transparent. They are not there. Okay. So in fact, this is good for database, but the file system cannot do that. Integrity problems as well. Integrity means some constraints cannot be easily maintained. If you do something, maybe will hurt the integrity of another file, but you don't have knowledge about this one in advance, so you don't intentionally do that, violate that integrity, but in fact you did violate. So this is a trouble for users, right? It's also a trouble for the managers, okay? For the people who manage the data, so administrators, okay? For example, like the integrity constraints, for example, account balance is larger than 0 become buried in program code rather than being stated explicitly. So you coded this one in your code, but you don't use this one as a constraint in your data. So if you put this one as a constraint in your data, means that when you create a table, you already have this constraint there, and then every time when you do a update, delete, or anything, they will check whether this constraint has been met. If it is not met, this transaction cannot be done completely, need to roll back. So this is automatically, but this one is buried in the code. If that piece of code will not be run during you perform that during performing that operation, so this integrity constraint cannot be maintained. Okay, so this is a problem. Okay, and also it is harder to add new constraints or changing existing ones, because you have to change all the code. Okay, whether it's adding a new or change the existing one, you have to check all the code. Okay, this one balance larger than 0. Maybe next time I want to say balance larger than 100 or 50, because this is the minimum allowed amount for account to maintain. So you have to check all the code, right? But for here it's easy, because we create a table, we have that schema, we can only change one time. That will applies to all the data. So if you decrease the account balance, if it's less than 0, it will not allow you to do that. Okay? It will not allow you to do that. So that means that this is also another issue for file system. Okay. And then the other one is atomicity. Atomicity is like just like, for example, I mentioned kind of like a transaction. If something can be done completely, do it. If something cannot be done completely, need to roll back, do nothing. Not means partially. For example, if it's partially, we leave the database in an inconsistent state, which will hurt the database. Correct? So this is the reason. So in our database, we have transaction management. So each operation is a small unit, is a transaction, smallest unit. So this smaller unit, like an atom. Atom cannot be divisible, okay? Cannot divide it further. So whether you want to have this atom or no, so it's only two options. Cannot do partially. I cannot break the atom into two parts. So this is the idea. So failures for the file system, you may just read partially, you may just save partially, and update partially, like these things. we put the file system in a inconsistent state. Okay, the file system, all the files. For example, like this one, we said transfer the funds from one account to other account. If you can do it, do it. If you cannot do it, so just not do it at all. Okay? So for example, should either complete or not happen at all. So in database we can do that. So but the file system has an issue to do this. Okay, but we can do that. So this also shows that means database can handle this one. File system cannot. Okay. So this is the purpose, the reason why we want to have a database. The other one is that we can allow multiple users to access the database at the same time. But the file system, we have the matrix-based control. In database, in operating system, we have that chapter. So in fact, we have, for example, which user have access to which one. So file one, you can do so read and write and appending. So like this one. So you have a control matrix. So for control matrix, that means sometimes we cannot allow two people to write, or cannot allow a read and a write together, because the write is doing updating. If we allow a reader to read, it will read maybe old data, not the latest one. So that means we have to do we call that one is just a critical section. We can only allow one writer at one time, at most one. Reader and reader can do that at the same time. But for here, there's no problem. If two users want to read the database at the same time, no problem. If one writer and one reader, no problem. We can do this one. Yeah, of course we need to have some mechanism. Later we talk about in a transaction. We make sure there's a consistency will be maintained. They may not do this one at the same time, but they will maintain their concurrency. That means one maybe do it first and then the other one do later. But during this time range, both transactions can progress. Okay. And here we mention about one example. So like uncontrolled concurrent accesses can lead to inconsistencies. For example, we have two people and reading a balance which is 100 and updating it by withdrawing money, say 50 each at the same time. Okay. So basically you can understand this is for example, there's one account, its balance is 100 and two people are reading this balance. Okay, one is reading, the other one is updating. So one will withdraw 50 from the account, the other one will read from this account at the same time. So this one, if we don't do the good concurrency, maintenance of concurrency, we may have a bad reading result or wrong reading results. Let me show you this example. So the account is 100, okay, and then there's the user 1, which is read, for example, okay, and the user 2 is withdraw 50. Withdraw 50. So for example, if we allow the reader to read during the time when the user 2 is withdrawing, So withdraw means it will first 100 minus 50. For example, because when we do the read, it's like this. We do the withdraw. We first load this amount into a register, which is 100, and then we use this one minus 50, get 50, and then save this back to the database. Correct? But if you allow this one to read during the withdrawal of the user 2, so you may read here before we update. You may read here. You may read here. If you read here, it's okay, correct? Because you have done read the account number into the register, and then deduct 50 from the register, get 50, and read it back. Correct? Read it back. So for here, also have an issue. Correct? So this one is 100. We haven't done the deduction. You read this one is okay. It's correct. It's wrong. Yeah, it's wrong because you need to read 50, but you read this user 2 after finish the transaction. The amount should be 50, but you still read 100. Okay, you think this account has 100, but in fact after finish this withdrawal, it's only 50. Correct? But this transaction is a whole. Correct? You can just let others to break the transaction. This is the main reason. And after we perform this one, you get 50, but it has not been read back to the 100. You still have issue. Correct? So only till here you read, and then it's correct. So during any time you read it is 100 because it's still the old one. You haven't wrote it back, written it back to the database. So this is called inconsistency. Inconsistency. It happens if we use a file system. We allow the user to break into the transaction running stage. Correct? So this is the reason. This is the main reason. And the other one is the security problems. So security, because it's a file, correct? You cannot only present a partial of a file. Correct? For example, the file is a table. You can have a name, birthday, maybe GPA. So if you want to show only the names, how can you show only partially? Correct? So in database, we can create a view, okay, for people who only have access on the names, just show names. For people who have access for all of them, show all of them, or part of them, show that part of them. So this is the reason. So we have more flexibility in database to control the security, control the data access. But for file system, just because it is a whole file, so it's not easy to hide something from others. Okay, so hide something from others just to guarantee the security, correct? Because some sensitive data should be not released to others, correct? So database offers solutions to all of the above problems. That's the reason we want to have a database. So here is a very good comparison between database and the file system. Correct? So we know the differences. Okay, so next one we have the important information. In fact, for this book, we use a Unix database example to explain the SQL relational schema database design and so on. A lot of the topics. So in fact, some students don't know. Maybe if you read the book, the preface, you know. But in case you don't know, I want to say. So in the appendix A of the textbook, you can find the university database examples, including its ER diagram, its relation schema, and its sample data. Let me show you. So I have the electronic version. So it's this one. So if you go to the book, okay, this is the 7th edition. Go to the end, almost the end. There's a part 10 appendix to here, and then you will have this appendix A, which is the university database. So it contains the ER diagram full schema. Okay? This is not the complete we cannot say this is real ER diagram because it's not a relationship there. But yeah, it's like a schema. Okay, schema diagram. It shows the important information, the entities and the relationships. File this, and this is reduced to the schemas. That means these are tables, cat tables. And then we underscore means these are the key, primary key. And then the definition, database definition language, that means create tables in SQL. So define the domain, the attribute, and their domains. Which one are primary keys? We have a classroom, department, course, instructor, section, and the teachers, and text, advisor, prerequisite, time slot, and also have a sample data populate each table. Okay, this is in the end of the book. So the page I mentioned here. So just refer to the book. You will get this information because some pre-access questions, that means also included in our assignments, may refer to this one. Refer to this relational database example. So for this one, data consists of information about students, instructors, and classes, and also maybe more, but it's just example. Mainly is instructors, students, instructors, and classes. Maybe we have something more: classrooms, departments, and so on. And then application program examples we can do. For example, application program example, that means, for example, you develop a web application to manage the university database. You may want to add, want to delete, want to update. This is our typical operation we want to do. Add new students, instructors, and courses. Register students for courses and generate class rosters. So register students for courses. So mainly for this one is done by students, but also can be done by maybe some program. What's the one? Just like they will manage the program degree auditor, they can do this one as well. Assign grades to students, so instructor can do that. Compute GPA, you can do that by retrieval the information. The database will do this one automatically. Will populate the related attributes based on the generated result. On the generated transcripts, yes, you can do that as well. Okay, so let's finish the last section. Maybe I know it will exceed our time by a little bit, but I will return the minutes to you for the next week. So just give you more time to do more homework. Okay. View of the data. So we already talked about database is important. Now we want to look at, if the database is important, how we handle the data. How can we create a database? So create a database, the core part is managing the data. So how to represent the data? So we want to answer this question. So a database system is a collection of interrelated data and a set of programs. Here we talk about two important concepts. The first one is data. So data, we need to know how to save the data. So later we talk about unit with tables, with relational database management system, DBMS. And then we use relational algebra to model data. But how to access data, we still need to rely on a set of programs we mentioned. For example, like a query, we want to evaluate this query in an efficient way. We want to get a result. Evaluate means how to implement, how to run. So we can, even the same SQL commands, clouds, we may use a different method to retrieve data. Some are quicker, some are slower. For example, if we do the query, we may need to join tables. Join table means we put two tables together, but based on some rules, not just only combine. But anyway, you think about it like a logic join. But whether you join table A, B first, and then join the result of A, B with C, or you join B, C first, and then with A, that will sometimes matter. This one is not equal to this one. I mean for speed, for some cases, not always, because you can find A and B join, maybe get a small table, maybe this one get a small table. If you already get a small table, you reduce the time to join with another one, so final result is smaller. This one may be bigger. So that means the units are different. They're different. So in your query evaluation, we'll do this one, optimize the best evaluation, best one, and then use that one to perform the query. Okay. So the major purpose of a database system is to provide the user with an abstract view of the data. So here we talk about two important things. The first one is the models, data model. The other one is the data abstraction. So I believe for data abstraction, maybe it's easy for you to understand abstraction. So you have learned the database. So how can we represent a collection of data? We need to use abstraction. For example, we use array to represent a list of something. We use a record to represent a student's information. So this is called data abstraction. That means data structure. So hide the complexity of data structures to represent data in a general way. So in the database from users through several levels of data abstraction. So for this one, let's use an example. For example, like with a student. So how to represent the student information? We use a list of attributes. So the first one, we give a name called ID. It means the student ID, SID, and the next one S, maybe S name. So we use this attribute to abstract the information in students, because each student will have a student ID. The attribute itself is the same, so each one has a student ID, but the value will be different. Each student have their own, have his or her own ID, his or her own name. So that means, but we do abstraction, so each one has the same information. Then we can create a table. So if we have a new student, we just add a new row. If we lose one student, we delete one. We add one, we delete one, add one, just like this. It's easy for us to maintain. So that's the only information we want to have as well. So we don't want to have something else. So this is the reason we want to do the data abstraction. Also, you can think about this is called why we said is SQL, structured query language. This is structured. So each one is the same. Each one is the same in terms of this data storage, data maintenance. So the other one is data models. So here the data in fact is larger than this one. It's larger than these domains. So this one is like, for example, this is the table 1, and then there's another table 2. So how these two tables are connected to each other, we need to use some conceptual tools to describe the data relationship, data semantics, and the consistent constraints. So this is the idea. You can also consider they can understand the low level one, but also can code the high level ones. So what is means data is easy to understand, student name and so on. Data relationship, for example, students register for courses, their relationship between is registration. So that means you may create another table called registration, we mentioned. So it's SID and then course ID. So then like this. And the data relationship, data semantics means the meaning, semantic meaning. For example, data semantics, the first SID means the student ID of a student. S-name means the name of student. This is called semantics. Consistent constraints, we have mentioned this one before, correct? Like a counter balance must be less than 0, student ID may be only 5 digits, and age must be less than 200, and so on, correct? Like this one. This is called constraint or foreign key references. And the other one is data abstraction. Okay, we already mentioned, correct? So this is two important things when we talk about database systems. So later when we talk about the relational algebra in chapter 2, we have a further explanation for this one. Now what you need to do is just understand, okay, so database is important, what are the reasons, and then how can we create a database? We need to use some models to understand, to model the data, and also we need to abstract the data fields. Okay, and then here we talk about the first one is data models. So we have definition for data models. What is data models? It's data relationship semantic constraint, we mentioned. And then we have several tools. We have a relational model. In fact, this one is the one most successful in the past and even till now, okay? And also the most important one for us to learn. We focus on the relational DBMS or DBMS. So that means for this one is based on relational schema or relational model, okay? And then we have ER data model. So this is relational model is for us to understand our DBMS, relational database, our DBMS, and the ER data model is for us to design, okay? Design the model. So we already explained, okay? What's the E, what's the R, and though we have other, but it's relatively less successful compared to this one. So we do have, for example, when the OOP is very popular, we also want to think about use object-based data models, object-oriented or object-relational, but not as successful as a relational model. Maybe the reason is that this is simpler, okay? Simpler. And then we have semi-structured data model, for example, like the XML, use the extensible markup language, okay, for this one. So you should use to represent a web page. And the other network model, because we think about, okay, it seems like the entities each other has a network, but still hard, okay? And then we have hierarchical models, for example, like expand like the group member information and the tree structure from one to the other levels, but still you can find it's slower, okay? Each time you need to reach the leaf, okay, from the top to the leaf. So not like this one is more direct. If something have a relationship, and then we have a data relationship for them. And let's look at the example here. For example, this is one example for the R model, okay, relational model. So for example, here we represent the relation as a table, okay? So the table has a table head, and then table head has the attribute ID, name, department name, and salary. So this is for the instructor, so has this information. And each one we said is a column or is an attribute. Each one, this is rows, okay? Rows and columns. These are attributes, these are rows. Rows is a record. We also means this is record. Record means a complete item for this instance of the belonging to this table, okay? So in fact, this was created by TED code. Even till now, we're still using this one. So this scientist received the Turing Award in 1981 as well. Okay. So in the later we'll have a lot of examples like this. Okay, the ID and also have the domain name, have domain. For example, this one can be integer, this one must be string, this one string, this one also integer. Okay. So we store the data in different tables, and the table has relationships. For example, for here, the department name must be existing in a department table. Okay? If you have a instructor coming from maybe astronomics, but there's no astronomics department from the department table, then it will violate the consistency. Will not allow you to insert that instructor. Okay? And also for this one, each one also have a domain. You must follow the domain. Okay? Like we create an integer array, then will not allow you to input maybe float. Okay? And then here we have a sample relational database. So the previous one, instructor, and then added the department table. Okay, so that means this one will refer. Okay, so this is called a foreign key reference. So it's not the key for this one, but it's a key for this one. Okay, department name is different. ID is the key for here, and this one is the department name, is the primary key. Okay, so next one we talk about the levels of abstractions. Okay, level of abstraction. So for here we have 3 levels, easy to understand. The lowest level is the storage, physical level, and then on top of this one is the logic level, and then on top of this one is the view level. Okay? So this idea, logical level, physical level describes how a record is stored. So that means we want to improve the efficiency. We want to store the data in a efficient way, in a good way. Okay? So for example, if you retrieve data close to each other, we also want to put them close to each other. So if you retrieve class information, each class may be put together, or department, though we allow students to register for other department courses, but mainly each department, the students register for their own subject courses. Okay? I mean, subject means they are major related courses. Okay? So we may need to separate it like this. We put those data for computer science put together, for math, for physics, for each of major, put them together. So this is how we arrange data in physical layer. Okay? Logical level, that means how we understand the data. Though the data is physically safe like that, but we access the data in a logical way. For example, the table. Okay? Like I prefer the table. So the table is a logical organization of the instructor and the department. So that's how we perceive the database. And then this database have instructor, department, and students, courses, and maybe sections and so on. Okay, a lot of things, registrations. So that's how we understand the database. It just tables. Okay, table 1, table 2, table 3. Okay, like this way. That's how we understand. And data is stored, okay, based on the disk. And disk we have sectors. So we may save similar data in one sector, close to each other. That's related to the operating system. Okay? So describes data stored in database and the relationships among the data. For example, like this one. So this is how we understand an instructor table. Okay? We do have more, but here is like the logic understanding of the data related to instructor. You can also say instruct data. how we understand instructor data. You don't care how this ID names, department name and salary. You don't care whether they're saving in a consecutive way or separately in different track. You don't need to have such concern. What is important for you is that how the instructor table, which domain, which attributes it has, right? Okay, have ID, name, department name, salary. That's important. That's already enough. Okay, view level is like we mentioned. We just want to hide some information from some that means illegal, maybe concerning illegal users. So hide some data from illegal users. You don't want to share all the information every time to all the users, right? So you create views based on the table, based on the logic level. You create this one. You may only select some of them, put here. You may select some others, put here. So different user group will access different parts of the data of the same table or a query, right? You create a query based on several tables, but you get maybe a lot of information, but you chop them into different views. For this one present to you, this one present to him, this one present to her, right? Like this. And the application program hide the details of data types. Okay. We typical thing is hide. So for data security, okay. So for example, we don't want to share the salary for security purpose for some persons who don't have the access, okay. So this is put all of them together like this way: physical level, logical level, and view level. Okay. So for this one, maybe it's for different applications, okay, for different user interface. For example, for you, you can look at your own record. Maybe for me, I can look at each of you, but for another person, maybe even can change. Okay? Another person, for example, like the staff, some staff which have the access to those things, they maybe can change. They register you for a course, they change something. Okay. Okay, this is I think this is all the information I want to cover in this first week, and then we'll continue for the next. So today we exited maybe sometime. I will announce this one when we release the lectures, and then we'll give the time to you back in the next week. So overall, now you already can start to read the book, read the syllabus first book, and then do some homework assignments. Yeah, you can, if you can do some, do it. Then you can read something, do them, and then prepare well for the group formation. I will try to announce the projects latest by next week, because I have to modify, make sure the consistency, right, as well. Okay, it's for your version, not for the last year. Right? Okay, that's all. I wish you have a nice weekend. Maybe it's too early, but tomorrow I will have another course, maybe for many of you, and then see you tomorrow. Okay, bye bye.